Here is very important question once again. Question number 1 of exercise 1.3 of chapter 1. It says prove that under root 5 is an irrational number. So let us see how to solve this question. First let us assume that to the contrary, that under root 5 is rational. And if under root 5 is rational, then it must be equals to p by q, where q is not equals to 0. P and q are integers. And very important result here, that HCF of these two numbers p and q equals to 1. This means p and q have no common factor other than 1. And rearranging this equation, we have p equals to under root 5q. Squaring both sides this equation, we get p square equals to 5q square, and we let this is the equation number 1. And what we observe here in this equation, we observe that the value of p square is 5q square. This implies that p square is divisible by 5. Therefore, p is also divisible by 5. So we can conclude with these two lines that 5 is a factor of p, and we shall use this result in the last of this solution. This is very important line. Now we shall put p equals to 5c in equation 1, and after putting p equals to 5c in equation 1, we get 5q square equals to square of 5c, and we can calculate it. This is 25c square, and therefore 5q square equals to 5c square. Now cancelling out 5 from both the sides, we get q square equals to 5c square. And what we observe here, we observe that the value of q square is 5c square. Therefore, we conclude that q square is divisible by 5, and by the theorem we have studied in theorem 1.3, we have studied earlier, that says q, therefore q is also divisible by 5. Now we can easily conclude that 5 is a factor of q. Therefore, 5 is a factor of both p and q. We can understand it from here, because 5 is a factor here. We have proved it, and we see that 5 is a factor of p here also. So we conclude that 5 is a common factor of p and q. This means P and Q have another common factor other than 1. Therefore, HCF of P and Q equals to 5. This contradicts our assumption that under root 5 is rational. Therefore, under root 5 is uh, is an irrational. Thank you.